Hello, my people. How are you? How you doing? Hope you are doing great. How una be? I hope una don eat small thing this morning. Always remember my advice. I say when you wan attend class, make sure say you eat something. If na beans, eat beans. If beans no dey for you at all, swallow garri. If garri no dey, find madiga, eat. Remember my advice. I no want something wey person go come dey faint here say we go begin to dey run up and down o. Now, in a case where you no get beans, you no get garri to swallow and you no get madiga to eat, find salt put for garri, put water, drink am, soak and drink. Una know the pattern na. Once upon a time, me sef na so I bin dey do. Now, if you feel say you no get garri to even soak, carry salt put for water drink. Make sure say you something enter your belle. Now, na your usual man wey you know, Dr. AMG. Now today we go continue with those our class dem wey we dey do. Now wey I know say una carry something put for belle come. The series wey we dey do now, we don give am new code o. Dat code na mass 1MTH102. Na im be the code o. Now, inside MTH102, wetin be the thing wey the topic wey we get wey we dey learn? The general topic wey we get na calculus. Na im we dey learn since. Na inside calculus wey we go come dey do things about differentiation and integration. Na im we dey try to learn those things wey go help us well well when we don enter integration and integration. Wetin the thing really mean, na im we dey learn so small small. Now today, you know say we don start dey talk about functions dem. Now today we wan know when function be even and when function be odd. When we see function, how we go use know when that function na even and when that function na odd function. Now, if e no be even, e no be odd, then wetin dey come be? E mean say e no be any of them now. Make we see as e be. So today, as I dey talk, we go learn when functions be even functions and when they be odd functions. Now, how we go use know when function dey even or function dey odd? We get two major ways wey we go use know when functions dey even or not. Now, one of them na algebraically. One of them na algebraically. Then the other one na graphically. Graphically. So for us to know whether function dey even or odd, we go fit know am through this means or this means. Oya, make we begin to dey do them one by follow. Now, first of all, the first thing I wan talk, the first one wey I go talk, na the algebraic means. Algebraic means. Now, wetin that one come mean? Now, see, since wey we dey learn, you know say we dey talk about function. Oya, make we see as that one come be. If you come say make we consider one function, say that function na f of x, we dey say that function f of x go dey even or e go dey odd, or you know go either even or odd if we do something. See wetin we wan do. Now, if you get this function f of x, come carry change this one wey dey inside. You know say this one wey dey here now, wey dey inside na the domain of that function wey we don learn now. This one na the domain o. Now, the domain of that function, that x wey dey inside, now make you put instead of x now, anywhere you see x, make you put minus x. If you put minus x inside the thing where you get, the relation where you go get, now if you can't solve am, you can see say the thing can't go back to wetin you been start, wetin you been get. This kind of thing means say that function dey even. Even. Remember, if they give you one function, or say you get one function, wey be f of x, now make you come carry minus put for that x. Anywhere you see x, put minus x, put am see. If you come solve am, you come see say the thing give you the same, and say that thing na even function. Now what if we come put the same minus x for where x dey, then we come see say minus dey outside, we carry minus come outside, but minus dey, we fit comot minus inside the function, then come write the other one, come get the other one like this. Then we say that kind one, e dey odd. That kind one dey odd. If we put the minus x inside the function, and after solving, we come see say we fit write am like this, then we say that one dey odd. Now, if we come put am again, then e no come give us either even, e no come give us odd. Then we say that one dey neither even nor odd. So 3 cases. Either it be even, either it be odd, or you say neither of them. Now the one way you go use, na the algebraic way wey you go fit use determine when function dey even or not. Now before I give you some example dem make we follow, make I talk about that of the graphical one. This graphical one wey dey here now, see the way that one dey. Say maybe if we get function, you come plot graph. Your graph come dey like this. No say this your y-axis, this one na your x-axis. If you come plot another graph again, your graph come dey like this. Dey go. You know say this is your x-axis, this one na your y-axis. Dey go. Now, this graph here now, wey we see here now, you see say when you dey look am for this one wey stand like this straight one, you dey see say the graph dey resemble. E dey resemble. This side and this side, you see say e resemble. This side and this side, you see say e resemble. If you turn this one like this, like you fold this one, you go see say e go cover this side. If you fold this one, e go cover this side. This kind of thing, my mother with us, if they say the thing dey symmetrical, say e resemble. E dey resemble when you look am in this way the thing you stand. So we dey say this one is symmetrical about the y-axis. When the function is symmetrical about the y-axis, then we say that that function dey even. This one here now, na even function. E go dey even when e dey symmetrical about the y-axis. Now this other one, we go say this one, if you look now, e dey like this. Now, if you look at like this and like this, the other one now like this, we dey look at this one now, we dey look at to that. Say this one dey like this, e come dey like this. So for this line now, you say this side dey the same thing. If you carry this one now, if you put am this side, you go fit still enter too. So this one are they symmetrical about the x-axis. This one are for y-axis. Whereas that one are for the x-axis. If they look for this one way lie down, you see say e resemble. So this one dey like this one dey like this. Now this one wey dey like this, you see this one an odd function. So we say when it is symmetrical about the x-axis, then we say then it is an odd function. It is an odd function. So when you see this kind of graph, that one they even with the symmetrical about the y-axis, whereas this one will be symmetrical about the x-axis. Nah, even odd function. Now make we consider some example based on for the algebraic one we will be the top, so that we will fit use and explain the thing well. Now, if we consider this example, where we're going to say, determine algebraically whether the function is even, odd, or neither. Now, the function we want to consider, given that f of x, the function be minus 2x raised to the power 2 plus 3. If the function be like that, how we want use know? Remember, we don't tell you, say, when we don't get the function like that, algebraically, say, make we put minus x anywhere you see x. If it be like this, then like this. If it happen like this, then like this. Then if it no be any of them, say that neither. Now make we see it. This is the function, this one will be the function we will get. Now, we say, make we put minus x. If we put minus x, for anywhere you see x, means anywhere we see x here now, we will put minus x. So, first of all, we'll get minus 2 for front. But where x there now, we put minus x plus 3. This one is plus 3 way there. Now, if you look this one, this side there, but this one now raised to power 2. Minus times minus will give you plus. So this side will get this one raised to power 2 back plus 3. Now if you look this one, you go see say this one don't go back to this one where we get will be f of x. And the thing where we dey try to talk, meaning that function they even, because we say when we put the minus x inside the function, and if the answer they the same thing as the other one, say that one they even, meaning say this one na even function. That one na even function. Now maybe we consider another one. Where the function we will get now 4x raised to the power 3 minus 2x. If now be the function, what we go on do? Based on what we don't do before. Remember, say this one now be the function though. Now, and for that of Anywhere we see x, we don't say make we put minus x. Minus x. So, meaning 4 minus x raised to power 3 minus 2. This one have x there, so you say minus x. Now this one, minus times minus will give you plus. Times minus again, it go minus. So this one wey dey here, we go still get minus. Minus x raised to power 3. Now this one minus times this minus will give us plus, so we get plus 2x. This one na be the answer. Make we see whether we go fit. This one we will get now, it resemble the first one? No, it don't resemble the first one, the answer. It don't resemble the first one. Now, make we try to see whether we go fit carry minus from inside out, then what it will come resemble the up one. Now, if we bring minus out, then means, if we don't bring minus out, means we will come out this minus so that we will get 4 x raised to power 3. Then here na plus before, so we go put minus so that this when this minus times and we will get this one back so that we get 2x. Now when you look at this one now, you now see say this one and the first one now resemble when we bring out minus. So it resemble this one, and you know say that's why they inside the bracket and it be the f of x. So means we don't bring minus out, then it come be f of x. Say meaning that one na odd function. So this function wey we get say na odd function. The first one wey we do na even function. This one na odd function. We fit still consider some example more, make we see as the thing dey go one by one. Now if we say let's consider the following, make we speak make we speak small baking for here, so that I will just put plenty one time. Determine algebraically the following functions, the following whether the functions below, following whether the functions below are odd, even, or neither. And wetin be the functions dem wey we get? One of them na x raised to power 3 minus square minus 3x plus 1. Second one na 7 all over x squared plus 6. Third one na 2x squared minus 2x plus 3. Then fourth one na 3x raised to power 3 minus 2x raised to power 2 minus 3x plus 1. Now make we begin to look them one by follow. Whether dem dey odd, if you know dey odd, whether e dey even, if you know dey even, whether e be neither. See the condition dem, make I comot am so that we go fit use this side use solve small mathematics. Now the first one wey we get na the function f of x na x raised to power 3 minus 2x squared minus 3x plus 1. Now we don't say make we put minus x inside, meaning anywhere you see x, put this. Anywhere you see x, put minus this, minus 3 into minus x plus 1. Now so it be. Now this one means minus times minus will give you plus times minus will give you minus x. Minus x raised to the power 3, that one remain. We get minus 2, then minus times minus here will give you plus. So this one give you this one square. This times this will give you plus. So we get this 10 plus 1. This one na the answer. Now make we look whether the thing dey even or odd. Make we look whether the thing dey even or odd. Make we look whether the thing dey even or odd. Now for the even, we don't say wetin we don't get now go resemble this one. But if you look this one, they don't resemble. Because here now, this one already na minus. So no be that kind one. This one resemble. This one sef no even resemble. Now make we come look the other case. Whether if we bring minus out, whether it will resemble the other one. Means first of all, it no be even. Now if we come bring minus out, means this one go be x raised to the power 3. This one sef go be plus 2x raised to the power 2. This one will be minus 3x. This one will be minus 1. Now, this one will be inside, and this one, they resemble, they don't resemble because this one here minus a, here plus a. Here plus a, here minus a. So this one self no resemble. Now, we don't test, you know, even they even, you know, even they odd. Means the thing na neither. So we say this function is neither even nor odd. This one is neither. Now make we consider this one wey dey for here. When we say f of x is equal to 7 all over x raised to the power 2 plus 6. That means when we don't put minus x, wetin e come be? We go get 7 all over minus x all squared plus 6. While this one, minus times minus will give you plus. So this one will come dey the same thing as 7 all over x squared plus 6. Now if you look this one, and the first one, they resemble. So you just conclude say that one dey even. This one are neither, but this one dey even. Make we do the third one quick, so that it will help us really understand wetin we dey do. Now, if we consider the third one they say we get f of x now 2x squared minus 2x plus 3. This one, so if we come put, anywhere we see x, if we come put minus x, wetin go come happen? Means you get minus x all squared minus 2 all into x plus 3. So this one now will give you plus, because minus and minus will give you plus, so you get 2x squared. This one will give you plus 2x plus 3. Now this one and that one, they resemble. If you look, they don't resemble. So you know they even, they don't resemble. Because here minus a, here now plus a. Now make we bring minus out to c. If we bring minus out, that means here itself will be minus 2x squared. Here will be minus 2x. Here will be minus 3. Now this one, or this one where we get here, now you see say the problem don't they? This one come out, but this inside no still resemble this one. So this one said no dey even. And if we say if the thing no dey even, you know also dey odd. You know, because this one are not even dey odd. So if you know dey odd, say we say the thing na like that. So this one wey dey self, this function where we get self, say na neither. It's neither. It's neither even nor odd. It's neither even nor odd. Now, honestly say the thing very simple to test. So this one, I want to make Honor test this one. I want to make Honor test this one so that Honor will show me the answer. We will discuss the answer after now. Now wey we don't know when function dey even and odd, the next thing I want make we talk about na composition of functions. The next thing I want make we talk about na composition of functions. Composition of functions. Now, wetin be composition of functions? Now, composition means to bring together, to put together. But make una remember say for the other class dem wey we don learn pass, we don learn something about to bring functions together before. In that one we say algebraic combination of functions. And that one we been dey talk about how we go use add, subtract and times functions dem. But this one no be that kind one. But rather how we wan use mix functions together. Now see wetin I dey try to talk. Make we see say f, make we take say f na one function. G sef na another function. We come believe say x na im be their domain. Is their domain. X na their domain. If x na their domain, e mean say f na function of x and g sef na also function of x. Now, for composition of function, wetin we dey try talk be say instead of f to where e domain na x, the domain go be another function again. Function na im dey as a domain of another function instead of just this x wey we dey get. Now wetin I dey try to talk be say if we get this one mean say f composition, this small knot wey una dey see here means f composition g of x. E mean say we get f but say g of x say na im be the domain of this f, like the way e dey here. This one na x na im be the domain. But for this one now, na f, I mean g of x na im be the domain of this function. Now this kind thing na im we wan see. So you go see say another function be domain for another function. That kind thing na im we wan learn. So make we see some example wey the thing go help us. But before I talk about the example, make I give a small definition wey e go help us use remember wetin we dey talk. Now when I dey try to talk be say if the range of the function, if the range of the function g is contained in the domain of the function f, then the composition which is f of g is the function defined on the domain of g by setting by setting this one. Now this one wey we don talk, you just like say like those ones wey like if the person give you say maybe f of x is equal to 2x plus 5. You come say make we evaluate am at 2. So anywhere you see x, make you put 2. Now so the thing will be. This one here now, anywhere you see x for f of x, you go come put g of x. Now that kind of thing we dey try to talk for here. So now when we don't take this one, make we consider small example so that we will understand wetin we dey talk well well. So that we will understand wetin we dey talk well well. Now, suppose say, example, suppose say g of x na x raised to 2 and f of x na x plus 1. Suppose say these ones na two function. Say make we come find, f composition g of x. Say make we find f composition g of x. Now if we get this one, say make we find am, you go see say based on that definition wey we get, say this one wey we dey here, wey be f composition g of x, say is the same thing as f make this g of x be the domain of f. Meaning f na it be this. No say f na it be this. So anywhere we see x, make you put g of x. Meaning say this one is equal to g of x, because we say anywhere we see x, make we put g of x. So g of x plus 1. Because anywhere we see x now, we don't put g of x. And your g of x, you know say this one na be this. Meaning say this one na x raised over 2 plus 1. So this one wey we get here now, na it be f composition g of x. Now, make we consider another example again. What of if we still get g is equal to this, and f na still this one, but dem come tell us say make we find g composition f of x. Remember the other one na f composition g, but now make this one be g composition f. Meaning say, based on that definition, meaning say, inside g, anywhere you see x, say make you put f of x, na it be the meaning. Now, but you know say this one na it be the g, so meaning we go carry f of x put inside g. So wetin this one mean say f of x, we don put the f of x inside where the x dey. But you know say your f of x na it be this one. So mean say this one na x plus 1 all squared. Now, first of all, f of g of x, f composition g, na this one be the answer. Now, g composition f, this one be the answer. Now, if you look this one and this one, the thing dem no be the same. So wetin I dey try to write, or wetin I wan make we know, na say even if the things dem na the same thing, say but once you don write am differently, say the answer wey you go get no be the same. Now wetin I dey mean be say f composition g all of x is not equal to g composition f all of x, based on wetin we don find there. So now that we don't know this one, I want make we briefly look another example wey go help us do small thing. Know say the topic na composition of functions. Composition of functions. So now make we consider on the example again. And this example now, f of x, we get them as x raised to the power 2 minus 5, and make g of x be 1 all over x plus 1. Now what we define now? F composition g all of x. And we say when you get this one, what thing we go come do? What thing we go come do? We don't say when you get this kind one, you go just say make g be the domain, make g of x be the domain of f of x. So meaning for f of x where you get, anywhere you see x, make you put g of x. Now where be f of x? This one will be the f of x. So anywhere you see x, say we go put g of x. Now the thing we want to do. So meaning this one, they equal to this one at x, so we are putting g of x. So we say g of x all squared minus 5. But you don't say g of x now be this one. So we get 1 all over x plus 1 all squared minus 5. So this one we will get here now in the f composition g of x. Now if that one did like that, then make we come look. Another one, for this one I for like make una do, but some people say, I never still understand what they talk of. Then if not so, then make I still write small so that una will understand. Make we still do some so that una will understand. What if I can't say, make you find this composition, this, where f of x is equal to 1 all over x plus x squared. Then g of x can be x squared. G of x can be x squared plus 1 all over x raised to the power 4 plus 1. Now, but they say make we find this one. Meaning say, this one means say f of g of x. That's the way we get. Anywhere you see x for f, say you go come put g of x. That is it. Now this one are f of x. Anywhere you see x, say we could put g of x inside there. So meaning say this one, you go feel write them as 1 all over g of x plus g of x all raised to the power 2. Now the thing we did for here. For the f of x, anywhere you see x, you say you put g of x. So now the thing we don't go there. So, but you know the g of x now be this. So you feel see put this one as 1 all over x raised to the power 2 plus 1 all into x raised to the power 4 plus 1. Okay? Plus the other one now, x raised to the power 2 plus 1 all x raised to the power 4 plus 1 all squared. All squared. And the same way we get. Now this one now, if you try to the right hand, it will come be x raised to the power 4 plus 1, x2 plus 1, plus x2 plus 1, x raised to the power 4 plus 1, all squared. You feel still simplify and go small. That one I will give on as for example. Now, all the cases where we don't look, even as they remember well, you see, say now, just f of x. One of it, the things, then the function, then they more than 2. And say, maybe we find that composition, whether we go fit. Yes, we go fit. And provided that composition, we go fit, even if then they more than 2. So, maybe we consider one way past 2. Maybe we see whether we fit, find their composition. Maybe we look whether we go fit, find their composition. Now, if we get f of x be 1 all over x, then we're going to get g of x. That one can be x plus 2. And we're going to get h of x. Make h of x be x raised to the power 2 plus 1 all raised to the power 2. if we get this kind of thing, then the question will be say, make you find F composition, G composition, H all of X. If you get this kind of thing, what you go come do? If you get this kind of thing, what you go come do? This one sef dey very simple. Wetin you go just do now, this one just say, you go carry this one, put inside, make this one be the domain of this one. Then this two now will be the domain of this other one. Now the thing wey dey. Now make I write wetin I dey try to talk. First of all, this first one. This one means, make I write everything first. Say F, G, H, where H is the domain of this one. Then this one is the domain of this other one. I think we're there. So if you want to find this kind of thing, you go find this one first. Then you go carry the answer, make the domain of this other one. So make we find this one first. What will be G of H of X? Means in G of X, anywhere you see X, make you put H of X. So this one will be the G of X. We see X here now. So make this one come here. So this one means we get x2 plus 1 all squared for the H of X, then plus all squared plus 2. And the thing we will get for this one. Now this one we're going to use put and make it be the domain of this one. Meaning say anywhere we see X for F, say make we put this one. Now wetin be F of X now this one. Means say this one now finally, anywhere we see F of X, we go come, anywhere we see X, for F of X, say make we put this one. So we go come carry the answer, put there, where we get this. Now the thing where we get. So when you do this three, that one I go to the answer. But you see, say, first of all, we carry this one do first. We give us this before we go carry and put anywhere we see X for that of X. So now so the thing they, and you understand say the thing they go small, and it is very simple for people to also understand. The next one way I will want to talk about now. You see, say, the first of all, when we do these two, the answer na function. All the ones wey we do, the answer na function. Even this three wey we do self, say na function we get. It means say when you do F composition G of X, you go come get F of G of X, and the answer will be a function. Make we call that function big F of X. Now, what I want to do now, make we see whether we will fit from here, go back. And in like manner, if we get the time way we do 3, F composition G, composition H of X. So this one we feel write them as F this one, the answer wey we get sef wey I just clean sef you see say na another function. Okay, all of them na function. Now wetin we wan do now, say make we from this one go back, make we go find the F, G and the H. From this one make we go back, go find F and G. Na the thing wey I wan make we learn. Now if we wan do like that, e dey easy. Yes, e dey easy. E dey easy. Nothing wey dey for this world wey answer no dey. Anything wey happen for this world, answer dey. So make we consider another one. Example based on wetin I dey talk. Now wetin we dey talk now? Find the function G and H. Example. Find the function g and f. Find the function g and f such that f composition g of x is equal to f of x, big F of x. Then the question is if given that f of x is equal to x plus 1 all raised to the power 5. What we are doing here is say, find the function g of x, f of x, such that the composition of this now give this, where this one now this. Now in this case, it's very simple. Based on what we are looking for, say that two things now give you this thing. Say what will be those two things? That be the main question. Two things now give us those things. What will be those two things? If na me be una, the two things then they simple for me to see. It is simple because this one here now, if na me, that one na one function. Because this one now they use put inside one means the other function will be now x raised to the power 5. If you carry this one, put inside this one, then you will get this kind of thing. So wetin be our f, wetin be our g. But remember, they say g now it serve as the domain of f. So means say make I take say let's make my f be x raised to the power 5 and make my g of x be x plus 1. Now, so that f composition g all of x go dey equal to g of x, where anywhere you see x for f of x, we go put g of x. Now this is f of x, anywhere we see x, we go put g of x. So this one go dey equal to g of x all raised to the power 5. And g of x is equal to this, so that you have x plus 1 all raised to the power 5. And if you look now, it be the thing where we get. Meaning say, your f of x now this one, your g of x now this one. Potter. Make we consider another example again. Make we consider another example again. If we say the same question, say we find the function g and h such that this one now make big F be equal to 1 all over x minus 6. Now find f and g such that we have f combination of g all of x is equal to this big F. Even this one self, now 2, now you make up this one. And then say make f composition g give you the answer. Means inside here now 2 day. Now if now 2 day, what will be the functions then? Which one be f, which one be g? Now first of all, the functions then way if na me, where they here. This one where this thing where they here now one function. Then if this one they if na one function, meaning this one then put them inside another x, will be x minus this. Now so it be there before they carry this one put inside here. Then if now so it dey, which of them be f, which of them be g? Because they say make g serve as the domain of f. Now if na me, I go say make my f of x be this one, and make my g of x be this one. If na so it be, then F composition G all of X is the same thing as, is defined as, or this. So in F of X, anywhere you see X, put G of X. So in F of X, anywhere you see G, put G of X. That's the meaning. So what we do here now, in F of X, where is F of X? This is F of X. Put G of X. So we have G of X in place of this minus 6. And your G of X is what? This is your G of X. So you have 1 all over X minus 6. And if you look at, it resembles this one. So our G of X is this, our F of X is this. Now what of if the things dey more than 2? We no go fit find am. We go fit still find am. We go fit still find am. We go fit still find am. So make we consider one wey 3 functions na im dey. Where this time now we go find F, G, and H. Find F, G, and H such that F composition, G composition, H, all of X, such that this of X gives you F of X. If big F of X is equal to 1 all over the absolute value of X plus 3. Now this one now we are to find, we go find F, G, and H, meaning inside this place, and their composition, I give you this one, and they say this one, inside this place you get 3. Wetin be the 3 wey dey? If na me, inside here, look this under, inside here, this one na one function. If this one na one function, means something been there wey dem carry this one put inside, and if na so, then means say this kind thing sef been there before dem carry this one put for here. Then if na so e be, then another one go there. That one wey go there na 1 all over X. So this kind thing go there before dem go carry this one again put inside. Then carry this one put here, carry am put here. Now, this one, which one be G, which one be H, which one be F? Now the question. Which one be G, which one be H, which one be F? Because the way we dey use combine them, their composition na say F composition G, composition H. So as we been do for the first time, first of all, we will consider G composition this. So if na me, I go say, make my G of X, make it be X plus 3. And make my H of X be the absolute value of X. If na so it be, then G of H of X will be equal to, in G of X, anywhere you see X, say make you put H of X. So this is G of X. Anywhere I see X, say make I put H of X. So this one is equal to H of X plus 3. And your H of X is equal to this. So you say absolute value of X plus 3. Now the thing where I get for G of X. Now this one would now serve as the domain of that of the F of X. And F of X, if we don't take this one, then the F of X will be that 1 all over X. That will be the F of X. So wetin I dey try to talk, we say F of G of H of X will therefore put this one, which is this, as the image, as the domain of this one. Why the function are 1 all over X. So in place of X now, we are putting this, so we have 1 all over the absolute value of X plus 3. So what we are trying to say is that our F of X is equal to 1 all over X. G of X is X plus 3. Then H of X is the absolute value of x. So if I look this one now, I see say this one sef dey very simple, the simple well. This one we will just do now a composition of a vector, though coming from the final step back to the initial step. We will move from the answer, go find the function there. The last thing I would like to talk about here before I call am a day na inverse function. Inverse function. Inverse functions. That one sef dey simple well. Inverse functions. Now make we consider one function, say f of x. Or you say g of x. This one na function. Now the inverse of this function na something wey dey like this. The inverse of this one dey something like this. And the inverse of this one and this one, the inverse will be g of x. This one now na be the inverse. So our own now, if they give us function, say make we find the inverse. Now I get small definition wey I go give to help those people wey wan sabi book well. And they say the inverse of f of the function f, this one a definition though. The inverse of f denoted by this is the function that is defined on the range of f and satisfies the equation f into f inverse of x is equal to x for all x in the range of f. This one a definition. The inverse of a function f, which is denoted as this, is the function that is defined on the range of f, and which satisfies this, such for all x in the range of f. Now make we consider some example. For this one, me I like to go sharp. I don't want to speak plenty grammar. But for mathematics, if you speak plenty grammar, people no go dey understand and rather they will confuse they go. The definition why I don't give now, people are waiting in the talk again now. Make I explain and small, sharply, so that they will understand what in they talk. For example, make we consider small example. If we say f of x is equal to x raised to power 3. Now the question is find f inverse. Make you find f inverse. Now, what you go do? Based on what I talk. Some people say, sorry, you never talk anything though. Then make you listen. Sharp, 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 sharp. When they don't give you this kind of function, say make you find the inverse, wetin you go just do now? Say make t be this side wey dey here. And once you don write this one, you don finish. Hold on. All wetin you go do now, make this one the subject of the formula. Mean anything wey government dey with am, you kind of pack go this other side. So see wetin I wan do. For me to comot this one, I go multiply this up there here na 1 there. I go multiply this up there by 1/3. Now if I do like that, meaning I go do 1/3. If I times this one to x, 3 dey already, I don times am 1/3. So this and this go go, only this go remain. So you see that I don make x the subject, meaning this is what I have. Now the thing wey I get to this. So this one wey dey here na im be the inverse. Once I don make this one the x the subject of the formula, that one will be the inverse. But remember say this t na me just put am. So I go change am back to the x wey we get. So the inverse of this function therefore is x 1/3. Poto poto. Now make we consider another one to see whether we go fit do am. Make we consider this one again. If we say if f of x is equal to 3x minus 5. 3x minus 5. Now wetin be f inverse? Now based on wetin I teach una, I know say the sharp students dem don't understand. They will just say, so I say make we say let t be equal to 3x minus 5 this side. Now if you don't be, make we make x the subject. Meaning you go pack all the other things come this other side. First of all, make we carry this one go the other side. If you carry go this one na minus, if you don't cross this one, it will become plus. So we will get t plus 5. Now the thing we will get t plus 5. So that we go the one will remain now 3x. Now the next thing we go do now to comot the 3 so that only the x will remain. And for you to comot the 3, you go divide everything by 3. So you get t plus 5 divided by 3. So that x will remain. If you divide this one by 3 too, it don't go. This one na im be the inverse. But remember, say no be t we use start. Now x na im be the variable wey dey the equation. So we go write am like that. Where we go say x plus 5/3. Some people say, sir, the way you use write this one, I don't like am. If you don't like am, then you say you feel write am as x/3 plus 5/3. Even if you write am like this, that's still the same thing. Now, make I come give una one. That one now, I dey wan make una solve am by yourself. Because the thing wey the inverse, that one dey very simple. Unless say you fit do these things for primary school, for primary 6 or for secondary school small, you no do anything. Then if you don't do anything now, you're on your way, they go university. How are you just going to enter the university? Some people na forget, they don't forget. If you don't forget, make you go back, go look at. Look this thing well. Put your eye for ground. You go understand what they talk. Now, if we get another one, say f of x. And this time now, the f of x we get now 1 minus x raised to the power 3, then 1 raised to the power 5 plus 2. If we get this kind of thing. Now the question I say we could find the inverse. Inverse of f. What we going to do? I want me to do it. If they say we could find the inverse, what are you going to do? I like the sharp students there. They don't say, sir say, make we write any variable. For this one, I make I take t. In short, make I take p, make it not be like the t now, the only friend where I get. P be equal to this other side will be 1 minus x raised to the power 3 raised to the power 5, 1/5 everything plus 2. Now, he say make I pack everything past this side except the x. So first thing when you go pack na this one. Here now you dey plus, so if you carry come, you go become minus. So you have p minus 2 is equal to 1 minus x raised to power 3 raised to power 5. Now the next thing to comot na to multiply this power by 5 so that this one will cancel. If you do like that, you will get p raised to the power 5 because we are multiplying both sides by 5. So that when this one comes out, you get just 1 x raised to the power 3. Wetin we define no be minus x, so na x. So make we do something so that this one will become plus. For you to become plus, make you carry am come this side. Then carry this one go this side. If you carry this one cross the equal sign, it will become plus x. Then if you carry this one go plus go, it will become minus. So that we get minus p minus 2 all raised to the power 5. That's what we get. Now the next thing na to comot this 3 wey dey for up. For us to comot the 3 wey dey for up, we go divide them by 3, the up by 3. So everything, so we get, if we divide, we go come get this one minus p 2 raised to the power 5. Everything we go divide them by 3. This length. So this one we get now will be the inverse. So no say no be p we use start. Now we just bring them to use help us. So the original equation no get p. So in place of p now we go put the x. Now if we dey put like that, the answer will come be 1 minus x minus 2 raised to the power 5 all into 1 over 3. This one now the inverse of this one. Now class, today we don learn plenty things well well. Even I remember we don talk about even and odd functions. When functions dey even and then dey odd. And we don say we fit test those things algebraically and also graphically. And I don show una. For the graphical one, we say if the graph dey symmetrical about the x-axis, say that one dey odd. Now if it dey symmetrical about the y-axis, say that one dey even. Now algebraically, we don also test. Say that one, say make you input minus x inside the function. Now if e give you the same thing, say that thing dey even. Now if you no get the same thing, but you come bring minus out. If you bring minus out, e come give you the main thing, then say that one dey odd. But if e no give you either odd or even, then you say that thing na neither. After that one, we don learn composition of functions. For composition of functions, if una remember, I don say na how to bring functions together. But this one no be like that algebraic combination where we do addition, subtraction, and multiplication. But rather, instead, with this one come be a function na dey serve as a domain of another function. And we see how we use do am. And even in that one, una see the way we do, we find out all the answers na the functions. Then we come from the final answer, then they get the single ones that we use. This. Finally, now inverse of function. That one sharply, I don't also tell you. So the inverse now how to see how you go make the subject and then the variable where they give you use do the subject of the formula. And once you don't change and rearrange them like that, so that way you don't rearrange, now it be the inverse. For now, I will say, thank you very well. This thing then is simple. Anything one I don't understand, I'm gonna say ask question. So that when I teach more, I'm gonna talk about those things. But some of them now just they say, I like this one, I like this one. Any of them will still get problems. Some go find way they see me. Some go send a separate email. They give me. Say, make I explain this one for them. Now see, you don't need to send separate email. Give me. What you go just do now to go there, write them for the comment section. Say this place, make I listen. So that when I give video again, I go to explain those things. Give on them. For now, on a bye. And I want to thank you very well for as long as they attend my classes there. They make my belly the sweet, they go. Thank you, and thank you very much.